Hi, I'm Walter Grayman, representing the WDSA History Project. This is part of the Environmental and Water Resources Institute. And the purpose of the project is to try to capture the history of water distribution system analysis. An important part of it is a series of interviews that we're doing with key people who have done significant work in the water distribution system area. Our interview today is with Dr. Dominic Boccelli, who is a professor at the University of Cincinnati. Dominic's been active off and on in the distribution system area for the past 20 years. The interview is being done today in Austin, Texas on May 20th, 2015. Dominic, your original background was in chemistry and environmental engineering, and your PhD thesis was in the water treatment area. How did you get involved in water distribution system work?
Okay, so how I got interested in distribution system analysis, that's actually coming out of undergrad, the program that was more related, so chemistry background and an environmental engineering program that was more related to chemical engineering. Actually was interested in getting more into industrial wastewater treatment of all things, and when I was looking for my master's programs, I got the opportunity to go to Cincinnati. When I was looking for master's programs, I was really looking for something that had an experimental component and a computational component to it. That's really what I wanted in industrial wastewater treatment. But as it turns out, quite fortuitously, I guess, that I got a call from Jim Huber and Scott Summers, interested in looking at a project on booster chlorination. So a water quality project that was going to have experimental work looking at chlorine decay and disinfection byproduct formation, and some modeling, optimization, looking at how you optimally locate these booster stations to minimize the amount of chlorine you'd put in a system. And that's actually what got me primarily interested in both the distribution system area and systems analysis, so using optimizations for making decision support systems. Decision support. So I did that for my master's. I had the opportunity to stick around at UC for 3 years. They gave myself and my colleague Michael Tribby both the option of staying around for a third year and finalizing the research, or we could have moved on after 2 and they would have hired someone else. But he and I both stuck around, and because we were both really interested in the project, and wrapped that up. After that, I digressed a bit and went to Carnegie Mellon and was focusing more on the systems approach, and I went into looking at drinking water treatment and optimal design, incorporating uncertainty. And while I was there, I got back into kind of, as I was finishing up, talking with Jim Huber about a different topic. He was looking for another student to come back and work on a project that he had with Debbie Mole at the Centers for Disease Control. And it seemed to fit really well, and they were looking for a PhD student, and I said, well, how about a postdoc, because I was finishing up, and it was looking at doing tracer studies and trying to improve our ability to represent chlorine decay and DBP formation in distribution systems with a health impact. And
Can you tell us some about the field work? Field work always is a good source of stories. Talk a little bit about that, some of the people that you worked with in those field studies.
Sure. So that was my first foray into field studies, and so we did that down in Hillsborough County, outside of Tampa. We were doing combined tracer studies. We were using food grade salt and doing a lot of water quality monitoring, the chlorine and DBP analysis, and also getting some information from individual homes, which was being done with the CDC. And that was essentially led by Jim Huber. It was myself, and Stu Hooper was heavily involved with that. Marco Propato was heavily involved with that. So we were one of the first groups to go down there and do a really large field sampling effort in order to try and really get an idea of the hydraulics, or trying to improve hydraulics and improve our ability to represent the water quality, with the idea of basically being able to look at the health impacts from that. So it was quite an endeavor. You have to spend a lot of time with a lot of people, a lot of hard work. Who else was involved? Feng Sheng was involved with that. A couple other students whose names unfortunately are escaping me right now. But Morris Masley from the ASTDR, Jason was involved with that from ASTDR, and yeah, a lot of time dumping salt, 50-pound bags of salt into a large storage tank to get it pumped out. Went through a couple pumps that corroded from the high concentrations of salt. But we got a lot of really good data from that, and we're able to see that we're able to do reasonable job at representing the water quality.
We lost Stu Hooper a few years ago, quite tragically. Could you talk about Stu a little bit?
Yeah, Stu is a really good guy overall. Just a good person. Really like Stu a lot. He had a lot of energy. Really solid engineer. Solid person, was able to do well to communicate both through the computational stuff that we had to do, the experimental work that we did, field where he was really good at getting things ready for the field and keeping things organized and moving. Yeah, he played a large part in getting a lot of the equipment that we had, especially some of the trickier equipment, the THM samplers. Were notoriously kind of challenging. He had a lot of experience in doing that type of work actually while he was associated with Emory University and the CDC on getting that type of stuff done. And that relationship, so I worked with him a lot there, and then that relationship continued when I came back to Cincinnati as faculty, and he was with City Logics with Jim Huber and Sam Hatchett and the Northern Kentucky Field Studies. Where he also played a very significant role in how he designed and put those studies together. Yeah, Stu was a great guy, missed by many.
You joined the UC faculty, University of Cincinnati faculty. You've been doing work in chloramination, generally with MSX, EPA-NET. Can you talk about that and about some of your other work at UC?
Sure. Yeah, so the great thing about MSX was we were able to, multi-species extension for EPA-NET, it really gave us the opportunity to try out some more complicated models, and that generally work well at the bench scale, but never really were tested at how well they worked at the field scale because we didn't have those capabilities. So one of my first significant projects at UC was to be able to test out essentially a fairly extensive chloramine model that was developed by Richard Valentine and his coworkers at the University of Iowa. It was about 20 plus set of differential algebraic equations. Did very well at representing experimental research, the experimental data that was collected in the laboratory, but never really tested at the field scale level because there was no opportunities there to do so. So myself and student Matt Alexander, along with a couple other colleagues who else was down there. Ken Nilsson helped out down in that field study. Stu Hooper also again was down in the field study. Again, I feel like I'm missing some other. Jim Huber, Feng Sheng, were all part of that field study where we went down there and a different part of Hillsborough County and were able to collect data from 3 different treatment plants, looking at the different decay as well as a lot of samples out in the field. And we're able to run that through MSX and kind of see how well that model works. And amazingly enough, that model works reasonably well. It worked reasonably well even without a well-calibrated, or I shouldn't say without a well-calibrated hydraulic model, without doing it much more than what the utility done. And their advanced utility, they usually had a pretty good good handle on their hydraulics. But that was the first time I think we'd taken such a complex model, dealt with multiple sources, so we had to deal with different types of decay, and it worked. It represented the results very well. So kind of very nice field verification of a large-scale model.
You've been attending the EWRI conferences for many years. You're actually the current chair of the WDSA committee. Can you talk about that role and your participation in EWRI, how it's contributed, if it has?
Well, the conference has always been something I've looked to attend. Even when I was doing my PhD, even in the treatment area, I don't think I've missed any of these meetings since I started coming in '95 or '96. So they've always contributed to me, always been a good source of insight and knowledge and inspiration for what I'm going to be what I'm doing. The EWRI has been ASC/EWRI, because the EWRI started while all this was going on. Obviously ended up being a great home for the water distribution system analysis community. It kind of ended up being our rallying point, to the point where we've got this conference now that goes out on its own every couple of years, and always within ASC, EWRI, sometimes outside of it, and it's given us it's really brought our community together and provided us with a great forum to keep everyone together, and it's really made it, I think it's really made a difference, because it's helped to bring everyone together in a central location and allow things to develop. The sharing of ideas, collaborate on things, just learn from the various aspects of the various people, the various expertise of the various people that it's brought together.
You took a sabbatical in Australia, in Adelaide. I think you're going back there again.
Yes.
Can you talk a little bit about your experience there in terms of water distribution system work?
Yeah, that was yeah. So before the Australian WDSA, I was able to. I was graciously given the opportunity to go down there for 10 weeks and spend some time working with Angus Simpson and Martin Lambert and Aaron Zekin, Graham Dandy, Holger Meyer. So I worked with quite a bit of them, and yeah, it's helped move me forward in my. It was great for me because I got to learn something about the evolutionary computational aspects of it. We started the process of working on trying out some new water quality algorithms that we're still in the process of working on. Because, for example, models like MSX are still computationally challenging to work, to simulate for long periods of time. For example, right now, for like our study in Florida, it took almost 3-4 days to simulate a week's worth of data. So we'd like to improve those kinds of capabilities. So we've been working on newer approaches for trying to solve those water quality problems. Also did some work on some real world systems, helped out trying to, some of the field work that they had done with one of the systems down in Australia, trying to look at chloramine issues in their systems. And moving me, it started my move a little bit into my interest into pump scheduling, which was tied into the interest that I've had in real-time modeling. So, and yeah, I'm getting the opportunity to go back for another 4 months, and looking forward to it. I think we're going to be able to make some good inroads on a lot of these types of topics.
Looking into the future a little bit, I know you're spearheading an attempt to organize a water center, an interdisciplinary center at the University of Cincinnati. Talk about that and what else you see, or what you think should be done in our area.
Yeah, the water center. It's a good initiative. There's a lot of, while I spearheaded it, I think there's a lot of faculty there who are in engineering, arts and science, our planning group, which is in design, art, architecture, and planning, and ultimately some of the folks in medicine and environmental health. There's a lot of people that are interested in water research-related activities. And yeah, so we started trying to just informally get these group of people together, start to exchange ideas, what topics we want to work on. The urban water was one of the significant topics. Another topic is focused around algal blooms, how we can understand them, manage them, and keep them from impacting the population. And that's been going well. We've got the opportunity to hire 6 faculty over the next couple of years, and that's exciting to keep this interdisciplinary group going and growing. I think it's really important to try and take advantage of the various expertise that we have in solving water problems, because I think water issues are big problems and they require people from multiple fields, and hopefully the Water Center will morph into something more where we'll be able to really branch out and bring in people, things like resource economists, some more social science and policy related folks that would really start to strengthen our overall capabilities in the water field.
Anything else you'd like to add?
No, I don't think so. I don't think so.
We appreciate very much taking the time, and thank you.
Thank you, Walter.